The last normal thing Alex did was open the archive. Two space telescopes, 23 years apart, had photographed the same patch of sky without knowing it. IRAS launched in 1983, a joint mission between NASA, the Netherlands and the UK, the first telescope to survey the entire sky in infrared light back when infrared astronomy was still young enough to feel like a new sense the species had just grown. Akari, launched by Japan in 2006, doing roughly the same job with better eyes 23 years later over the same stretch of stars. Nobody had built either mission to find a planet. That wasn't the point. IRAS had been designed to catalogue infrared sources across the whole sky for the first time in history. Distant galaxies, forming stars, clouds of interstellar dust, and had done its job so thoroughly that astronomers were still mining its archive decades later for things its original builders had never imagined anyone would look for. Akari existed to do the same work again, better, with instruments a generation more sensitive, launched into a solar orbit that let it stare at the sky uninterrupted for months at a time. Alex was the one trying to make the two of them do something neither had ever been built to do: work together, 23 years apart, as a single instrument for catching motion too slow for either of them to have noticed alone. Her office was small and cluttered in the specific way astronomy offices tend to be. A desk buried under printouts nobody had thrown away yet, two monitors permanently displaying different star catalogues, a cup of tea gone cold hours earlier because remembering to drink it required attention she didn't have to spare. A postcard of the Whirlpool galaxy, sent by a former advisor years ago, was taped crookedly to the edge of one monitor, curling slightly at the corners from years of the room's dry heating. Outside the window, evening had already turned into night, and night was turning, slowly, into the particular kind of early morning where the building's other offices go dark one at a time until only a handful of windows are still lit at all. The idea was simple enough to explain in one sentence and hard enough to execute that it had taken most of a year. If something massive was orbiting the Sun far beyond Neptune, 5 to 10 times the mass of Earth, hundreds of times farther out than we are, moving so slowly across the sky that a human lifetime wasn't long enough to watch it complete a single orbit, then the only way to catch it moving at all was to compare two snapshots taken decades apart and look for a single point of light that had shifted position by an amount too small to notice in either image alone, but too large to be a coincidence once you lined the two pictures up and let the computer do the noticing instead. Here's what you need to know before anything else. In 2016, two astronomers at Caltech, Konstantin Batygin and Mike Brown, published a paper that reopened a question most of the field thought had been closed for a generation. 6 of the most distant known objects in the Kuiper Belt, icy bodies orbiting the Sun far past Neptune in stretched, elongated paths that take thousands of years to complete, shared something that shouldn't have been possible by chance. Their orbits pointed in roughly the same direction. Not identical, just clustered tightly enough that random chance made a poor explanation, the way 6 strangers all facing the same unmarked corner of an empty room makes you start looking for whatever they're all facing toward. One of those 6 objects was Sedna, a small, brutally cold world discovered in 2003, so distant and so slow that its entire known orbit takes over 10,000 years to complete. A world whose existence had already puzzled astronomers for over a decade before anyone connected it to 5 others sharing the same strange alignment. Sedna never comes anywhere near Neptune, never close enough for the giant planet's gravity to explain its strange, stretched path, which was precisely what made it such an uncomfortable puzzle for so long. An object clearly belonging to the solar system, following a path nothing in the solar system's known contents could adequately explain. Batygin and Brown's answer was that something was shepherding them. A planet nobody had ever seen, 5 to 10 times the mass of Earth, orbiting somewhere between 400 and 800 astronomical units from the Sun. Hundreds of times farther out than Neptune, so distant that sunlight itself would take the better part of a week to reach it, and the better part of another week to reflect back toward Earth. On a path so long it would take somewhere between 10 and 20,000 years to complete a single circuit. Not close enough or bright enough for any existing survey to have simply stumbled across it by accident. They called it Planet 9, mostly because Pluto no longer held the number and the joke wrote itself before anyone could stop it. Alex had been a graduate student the year that paper came out, young enough that it had felt less like history and more like an invitation. A decade later, the invitation still hadn't been answered. Nobody had photographed the planet. Every piece of evidence for it remained the same kind of evidence it had always been, not a picture, but a shadow, the gravitational fingerprint of something never directly seen, inferred from the way it seemed to be nudging everything smaller around it into unlikely alignment. She'd sat through enough conference talks by then to know the shape the field's patience was starting to take. Not despair exactly, but a certain practiced weariness, the tone of people who had watched a decade of promising candidates dissolve back into noise and had learned to keep their hope quiet until the data forced their hand. Which was why Alex had started looking somewhere nobody expects to find a planet, in data that was already decades old, gathering dust in an archive, collected by instruments that had never been looking for this in the first place. The method itself wasn't glamorous. It was, if anything, the least glamorous kind of astronomy there is. Pulling two full-sky infrared catalogues, cross-referencing every point of light in one against every point of light in the other, and throwing out everything that matched. Everything that hadn't moved was a star, a galaxy, a piece of background noise doing exactly what background noise is supposed to do: stay put. Alex started with just over 2 million candidate points of light. The first filter removed anything already catalogued as a known object: stars, galaxies, asteroids with well-documented orbits, the ordinary furniture of the sky. The second filter removed anything that hadn't moved at all between the two surveys, which was almost everything that remained. The third filter, the one that cost the most time to build, removed anything sitting too close to the bright, cluttered plane of the Milky Way itself, because a faint moving object hiding in that glare was, for all practical purposes, invisible, a single candle trying to be noticed inside a bonfire. What survived all three filters was 13 pairs of dots, 13 places in the sky where something had been photographed once in 1983, and again, faintly in a slightly different position, in 2006. Alex checked each of the 13 by eye, the way you'd check anything you didn't quite believe yet. And 12 of them fell apart under closer inspection. An instrument artifact here, a satellite trail nobody had flagged there, contamination from a source just bright enough to fool the algorithm and just faint enough that a first pass hadn't caught it. One of them didn't fall apart. The 2 points sat close enough together and moved by close enough to the right amount over the right span of years that the separation was consistent with a large, distant, slow-moving object, something with a mass and a distance in the range Batygin and Brown's models had predicted a decade earlier, orbiting somewhere nobody had ever managed to point a telescope at directly. Alex checked the coordinates against every catalogue she could think to check, then checked them again against catalogues she wasn't sure would even be relevant, the particular kind of over-thoroughness that comes from wanting badly enough not to be wrong that you start distrusting the wanting itself. Alex remembers staying in the office long after everyone else had gone home, running the same calculation 4 separate times, because the difference between a real discovery and an exciting mistake sometimes comes down to nothing more than whether you're willing to check a 4th time when 3 checks already gave you the answer you wanted. The building's heating had cycled off hours earlier, and the cold had started creeping into the office in that particular way old university buildings let it, but she barely noticed, the way you don't notice a room's temperature when every part of your attention is somewhere else entirely. The 4th check gave the same answer as the first 3. She called her collaborator that night, a researcher named Wei, 3 time zones away in Taiwan, who picked up on the second ring despite the hour, because both of them had long since stopped keeping astronomers' hours in any conventional sense. "Run it again on your end," Alex said, without preamble. "I don't trust my own excitement right now." "You never do," Wei said, already pulling up the files. There was a long pause on the line, the particular kind of silence that means someone is doing careful work rather than making conversation. "It's holding. Same separation, same implied motion. I'm getting the same numbers you are." "Say it plainly for me." "It's consistent with something out there," Wei said. "Doesn't mean it is something. Means we haven't found a reason yet to say it isn't." "How many ways have you tried to kill it?" "Every way I could think of before I called you back. Bad astrometric solution, checked. Known asteroid we somehow missed in the catalogue, checked, twice. Cosmic ray hit mimicking a point source in one of the 2 images, checked. The profile's wrong for that. I wanted it to break. It didn't break." Alex sat with that distinction for a long time after she hung up, because it was, she already knew, the only honest sentence either of them was going to be allowed to say publicly for a long time yet. They published the following year, careful in exactly the way every real discovery paper has to be careful, not claiming a planet, only claiming a candidate signal consistent with one, a single pair of faint dots in an ocean of 2 million discarded points, the kind of result that reads, to anyone who knows how this field actually works, as a beginning rather than an ending. The response was immediate, and it split cleanly into 2 kinds. The public response was almost uncomplicated. After a decade of indirect evidence, a hint of a photograph, however faint, however unconfirmed, felt like the first real sighting after 10 years of following footprints. Alex answered more interview requests in a single week than in the rest of her career combined. A radio producer asked her, on air, whether this meant the solar system would soon have 9 planets again, and Alex spent 30 careful seconds explaining that even in the best case, the object would need to be observed directly, its orbit confirmed, its classification debated by an international body, before anyone could responsibly say the word planet about it at all, and then watched the interview get clipped down online to 11 seconds that made it sound like she'd said yes. A late-night talk show host opened his monologue that week with a joke about Pluto finally getting revenge. Alex's own mother called to ask, cautiously, whether this meant Alex was about to become famous, and Alex told her, honestly, that she hoped not, because famous and correct rarely got to be the same word in this line of work for very long. The professional response was something else. Skepticism, mostly, the healthy, expected kind, the same kind every extraordinary claim in this field has to survive before it's allowed to matter. Colleagues asked pointed, fair questions about systematic errors in 23-year-old infrared data, about the plate matching algorithm, about whether 13 candidates surviving from 2 million was actually a meaningful signal or simply the number you'd expect from noise alone if you searched hard enough for long enough. One senior researcher, someone whose textbook Alex had studied from as an undergraduate, emailed a list of 11 questions so thorough that answering them properly took the better part of a week, and ended the email by saying, almost as an afterthought, that the questions weren't an attack, only what he'd have wanted asked of his own work at that stage, and that he hoped the candidate held up, because he'd been waiting a decade for exactly this kind of result too. And within days, one skeptic in particular did something no one else had thought to do quite that fast. He sat down and calculated the orbit. Mike Brown, one of the 2 astronomers who had proposed Planet 9 in the first place a decade earlier, and who had spent much of that decade waiting for exactly the kind of signal Alex's team had just published, ran the numbers on the candidate's implied trajectory. If the pair of dots really was one object photographed 23 years apart, its orbit wasn't tilted the way Planet 9 was supposed to be tilted. Batygin and Brown's models required an inclination of roughly 15 to 20 degrees from the plane the rest of the solar system moves in. A significant tilt, but a modest one. The kind of angle that lets a planet still make sense as part of the same family of orbits everything else in the solar system belongs to. The candidate's orbit, if it was real, was tilted by something closer to 120 degrees. Alex remembers reading that number and having to sit with it for a moment before the shape of what it actually meant caught up with her. A tilt that extreme didn't mean a slightly different version of Planet 9. It meant an object moving in something close to the opposite direction from every other planet in the solar system. A retrograde orbit, a path so far outside the family of motion every other body follows that it couldn't be explained by the same gravitational story Batygin and Brown had built a decade of careful modelling around. To understand why that mattered so much, it helps to picture the solar system the way astronomers actually picture it. Not as planets scattered randomly through space, but as a flattened disk, every major planet moving in roughly the same plane, in roughly the same direction, a leftover shape from the spinning cloud of gas and dust the whole system condensed out of 4.5 billion years ago. Planet 9, as originally proposed, was allowed to be a little unusual, tilted, distant, slow. But it still needed to belong to that same disk in a loose sense, still needed to have formed as part of the same general process everything else did, just flung outward and left to drift on a longer, lonelier path than its siblings. An object tilted by 120 degrees doesn't belong to that disk at all. It belongs to a different category of explanation entirely. Something captured from outside the system, perhaps, or flung onto a wildly different path by an encounter so violent it broke whatever gentler origin it might once have had. And there was a second problem sitting inside the first one, quieter but sharper. If this new object was real, and its orbit really was tilted that far from what Planet 9's orbit needed to be, the two objects couldn't coexist. Not stably, not for any meaningful span of time. Two massive bodies on that different a set of paths, both far out in the same general region, would destabilize each other over timescales far shorter than the age of the solar system. One of them would have to go. Which meant, if Alex's candidate turned out to be real, it wouldn't confirm Planet 9. It would very likely disprove it. "It's kind of remarkable," Brown said in an interview Alex read 3 times before she could make herself feel anything about it besides the flat, specific sting of watching your own discovery turn its blade around. That a paper meant to find evidence for Planet 9 may have actually found something that says we were wrong the entire time. Alex sat with that sentence for a long time. She thought about calling Way again and didn't. Mostly because there wasn't anything left to calculate that would change what the sentence already meant. Instead, she pulled up the original 2016 paper, the one that had felt like an invitation a decade earlier, and read the section on orbital inclination again, slowly, the way you reread something after learning it might be the beginning of its own undoing, rather than the thing it once seemed to be. She remembered printing that same paper out as a graduate student, highlighting whole paragraphs in yellow, certain she was reading the opening chapter of something she'd get to help finish one day. She still believed that, she just no longer knew which chapter she was actually standing inside. Nothing in the mathematics had changed, only what it might now be pointing toward. Here's a fact worth understanding, because it's the fact this entire field has quietly run on for 110 years. The search for a hidden planet at the edge of the solar system didn't start in 2016. It started in 1915 when the astronomer Percival Lowell proposed something he called Planet X to explain small, stubborn irregularities in the orbit of Uranus. Irregularities that seemed, however faintly, to point toward the gravitational tug of something massive and unseen, farther out than anything anyone had catalogued. Lowell spent the last years of his life certain he was closing in on something real. He built an observatory in Flagstaff, Arizona, specifically to continue the search, spending a fortune of his own family's money on equipment and calculations, running the predicted position of his hypothetical planet through hundreds of pages of hand computation, years before anyone had a machine to do it faster. He died in 1916 without finding it, and the search stalled for over a decade afterward, his observatory occupied with other work, his planet still just a prediction on paper. In 1929, the observatory hired a 22-year-old amateur astronomer from Kansas named Clyde Tombaugh, who had never attended college but had built his own telescopes from spare parts and mailed his hand-drawn planetary sketches to Lowell Observatory, hoping someone might notice his skill. Someone did. Tombaugh spent the next year photographing the same patches of sky nights apart and comparing them pair by pair using a machine called a blink comparator, a device that let an astronomer flip rapidly back and forth between two photographic plates of the same star field, so that anything that had moved between exposures would appear to jump against a background of perfectly still stars. It was, in essence, the same idea Alex would use 95 years later, with satellites instead of glass plates and a computer instead of a trained human eye. But the underlying logic hadn't changed at all. Find the one thing that moved in a sky otherwise built entirely out of things that don't. On February 18, 1930, after months of tedious comparison, Tombaugh found it. A faint point of light that jumped ever so slightly between two plates taken 6 days apart. It was named Pluto. For decades that felt like the end of the story. Then, slowly, it stopped fitting. Pluto turned out to be far too small, barely a fifth the mass of Earth's own moon, to have exerted the kind of gravitational tug Lowell's calculations required. And decades after that, better measurements of Neptune's mass revealed something even stranger. The irregularities in Uranus's orbit that had started the whole search in the first place had never been real. They were an error, a small mistake in how precisely 19th century astronomers had managed to weigh a planet 3 billion kilometers away. Lowell had spent his life chasing a ghost born out of a rounding error and had found something real anyway, just not the something he thought he was finding, and not for the reason he thought he was finding it. Pluto stayed regardless, reclassified once as the solar system's 9th planet, celebrated for 76 years in that role, taught to generations of schoolchildren as an unshakable fact of the sky. And reclassified again in 2006, the same year Akari launched, when the International Astronomical Union redefined the word planet precisely enough to leave Pluto outside its boundary, requiring, among other things, that a true planet must have gravitationally cleared its own orbital neighbourhood of other debris, a test Pluto had never passed, sharing its region of the Kuiper belt with countless other icy bodies of its own kind. It was demoted to a dwarf planet in the same decade its own accidental discovery's original justification had quietly stopped applying to anything at all. A planet found for the wrong reason, later undefined for a different, more careful one, the two mistakes separated by 76 years and having nothing to do with each other. Alex thought about Lowell more than once that year. A man entirely wrong about why he should have been looking, who ended up finding something anyway, just not the something he thought he was finding. She wondered, some nights, which version of that story she was currently living inside. There's a piece of the story that arrived from an entirely different direction only weeks later, and it made the picture more uncertain rather than less. An object called 2023 KQ14, nicknamed Ammonite by the team that found it, using Japan's Subaru telescope high on the summit of Mauna Kea, turned out to belong to the same rare class of extreme distant objects that had originally seeded the Planet 9 hypothesis in 2016. Only a handful of objects like it were known to exist anywhere in the solar system, a class called Sednoids after Sedna itself, the first and most famous member. Finding a new one should have strengthened the case, adding a fourth voice to a chorus that had only ever had 3 before. Instead, its orbit didn't align with the others at all. A researcher on the discovery team, Yukun Huang, put it plainly in the paper that followed. The mismatch didn't prove Planet 9 wasn't out there. It meant the original clustering, the thing the entire decade of searching had been built on top of, was weaker than anyone had wanted to admit. 4 sednoids were now known. Only 3 of them agreed with each other. There was other evidence that had never quite fit the simplest version of the story either. A separate population of small bodies called centaurs, objects that orbit in the gap between Jupiter and Neptune, included more than a dozen with highly inclined orbits, several moving in the opposite direction from every planet in the solar system, a population Batygin had pointed to years earlier as another natural consequence of a hidden ninth planet's gravity, evidence that had always sat slightly outside the cleaner story about the 6 original Kuiper Belt objects everyone talked about first. Maybe a planet had been there once, some researchers began to suggest, and had since been flung out of the solar system entirely by some ancient, violent gravitational encounter nobody witnessed and nothing recorded, leaving only its old gravitational footprints behind in the orbits it had shaped before it left. Like a house standing empty years after the family that built it had already gone somewhere no one thought to follow. Others argued the clustering had never needed a planet to explain it at all, that a big enough sample of distant objects, examined closely enough, would always throw up patterns that looked meaningful and weren't, the way a handful of coin flips can look like a streak before enough more flips wash the streak back into noise. Alex kept both possibilities on her desk at once, the way you keep 2 maps that disagree with each other, not because you expect either one to be perfectly right, but because throwing either one away before you're sure feels like a worse kind of wrong than holding 2 contradictions at once. There's a detail about the search itself worth sitting with, because it explains why an answer has taken this long to arrive at all. An object 5 to 10 times the mass of Earth, at a distance of 400 to 800 astronomical units, reflects an almost unimaginably small amount of sunlight back toward Earth, sunlight that has already travelled outward for hours before it even reaches the object, only to be reflected back across the same vast gulf a second time before any telescope on Earth has a chance of catching it. At that distance, the object would appear roughly 100,000 times fainter than Pluto did to the telescopes that first found it, moving so slowly across the sky that a full year of its motion might shift its apparent position by an amount smaller than the width of a single pixel in most existing sky surveys. It isn't hidden because nobody has looked. It's hidden because almost nothing built before now has been sensitive enough and patient enough and wide enough in its field of view to notice something that faint moving that slowly across that much sky. That, more than any single piece of evidence for or against it, is the real reason Planet 9 has remained a shadow for a full decade rather than a photograph. Batygin himself once compared the dynamics of the outer solar system to a game of soccer, with Neptune playing goalie. Every so often, an object from the Kuiper Belt gets knocked inward by some chance encounter, and Neptune's gravity, the first large mass it meets on its way in, tends to catch it, trapping it into a new, altered orbit before it can travel any farther. Over billions of years, that slow, repeated goalkeeping should have scattered the orbits of the outer solar system's most distant objects into something close to random. Batygin and Brown's argument was that a small number of them hadn't scattered randomly at all, which meant something else. Some quieter but more massive presence had to be doing some of the shepherding instead. Alex spent the months after Brown's recalculation doing the only thing that still felt honest, going back to the data instead of away from it. She and Wei reprocessed the same archive with a stricter set of assumptions, trying to see whether the signal survived being doubted as thoroughly as they could manage to doubt it themselves. They rebuilt the pipeline from scratch, rather than simply rerunning the old one, on the theory that a mistake baked into the original code would only replicate itself if they trusted their own past work too much. They pulled in a third independent infrared catalogue from a different mission entirely, hoping either to catch a third detection of the same object or to catch the whole signal quietly disappearing under a different set of eyes. It did, in the narrow technical sense, that the two original points of light were still there, still separated by the amount the numbers required. It did not survive being explained. Reprocessing couldn't tell them what the object actually was, only that something had, in fact, been photographed twice, 23 years apart, and that whatever it turned out to be, it wasn't nothing. "We didn't find Planet 9, Alex told a room of colleagues at a conference the following spring, choosing every word the way she'd learned to choose them over the past year. "We found something worth following up on. Those aren't the same sentence, and I'd rather be the person who says the smaller, true thing than the person who says the bigger thing that turns out not to hold." The room was quieter than she expected. A few people nodded. Someone in the back asked, not unkindly, whether she regretted publishing at all, given how quickly the recalculation had followed. Alex thought about it for longer than the silence in the room was probably comfortable with. "No," she said finally. "The candidate's still there whether or not we'd published it. Publishing meant someone smarter than us got to check our work in public instead of in private. That's not a failure of the process. That's the process working exactly the way it's supposed to." A colleague in the audience, someone who'd spent 30 years watching claims like this rise and fall, told her afterward that it was the most useful sentence anyone had said about the whole affair in over a year. There's a parallel worth naming here, one that keeps surfacing whenever a story like this gets told carefully enough. 230 million years ago, a different Alex stood on the supercontinent Pangaea, in a world still assembling itself into something that could someday support a species that asks questions like this one. More recently, another Alex watched a planet that had, impossibly, stopped turning. Still more recently, one Alex found a half-billion-year-old probe waiting silently at the edge of the solar system, carrying a message that arrived too late for anyone to answer. And another spent 2 years chasing a star that turned out to be nothing anyone had built. Dust and comets, not a civilization, not a home. Every one of them reached toward the edge of what could currently be explained, found something that briefly looked like it might mean everything, and then had to sit with what the evidence actually said once the excitement settled. None of them got to skip that part. None of them got to choose the ending in advance, no matter how carefully they did the work that led toward it. This Alex found 13 dots, then one, then a number, 120 degrees, that turned the discovery back against the very theory it was supposed to prove. Not disproof, not confirmation either. Something stranger and less comfortable than both. A signal that, if it holds up, means the searchers were right that something is out there and wrong about what it would turn out to mean. As of this summer, the newest and most powerful survey ever built for exactly this kind of search, the Vera C. Rubin Observatory, high in the mountains of Chile, equipped with the largest digital camera ever constructed for astronomy, a single instrument capable of photographing an area of sky many times the size of the full moon in one exposure, has begun its work. Where Lowell had one blurry photographic plate at a time, and Tombaugh compared plates taken nights apart by eye through a blink comparator, and Alex had 2 infrared snapshots separated by a human generation, Rubin will photograph the entire visible southern sky every few nights for a full decade, building not 2 snapshots to compare, but thousands, close enough together in time that something moving as slowly as Planet 9 would have almost nowhere left to hide. The observatory began issuing its first public alerts in late February, flagging anything in its images that had changed, brightened, dimmed, or moved since the last time the telescope had looked at the same patch of sky. A torrent of data large enough that no team of humans could review it directly, sorted instead by algorithms trained to flag exactly the kind of faint, slow motion a hidden planet would produce. Scientists who had spent a decade waiting for a single archived pair of dots were, for the first time, about to have an instrument built specifically to catch the thing moving in real time rather than reconstructing its motion afterward from old photographs never meant to find it. Nobody knows yet what it will find. maybe a real planet, tilted the modest amount the original theory required, quietly confirming a decade of careful, patient modelling. Maybe nothing where the theory said to look, and the quiet, unglamorous conclusion that the clustering was always coincidence dressed up as pattern, waiting for enough data to finally fall apart under its own weight. Maybe something stranger than either answer, a retrograde world that shouldn't exist under the current story at all, proving the searchers right about the search and wrong about the reason, the way Lowell had been 110 years earlier, entirely by accident. Maybe even more than one answer at once. A real planet on the modest tilt and a second, unrelated object out there too, its retrograde orbit belonging to some entirely separate story nobody has thought to tell yet. One question before we go. If the planet you spent your whole career looking for turned out to be real, but its existence proved that the reason you went looking in the first place was wrong, would you call that a discovery or a correction wearing a discovery's clothes? There's a version of this question that isn't really about a planet at all, the same way the earlier ones weren't really about aliens or dying stars. Most long searches for a diagnosis, for the cause of something broken, for the reason a pattern in your own life keeps repeating, eventually turn up an answer that's real but sideways from the one you went looking for, correct in a way that quietly rewrites the question rather than simply completing it. Lowell was wrong about Uranus and right that something was worth finding anyway. Alex might turn out to be wrong about Planet 9 and right that something out past Neptune has been waiting patiently the entire time for someone patient enough to notice it moving. Nobody gets to choose in advance which kind of ending 110 years of searching is going to produce. Lowell didn't get to know he was building toward a rounding error and a moon-sized world named after a Roman god of the underworld. Tombor didn't get to know that the 22-year-old amateur from Kansas with no college degree would end up the one person who actually found something on a night in February that started out exactly as ordinary as every other night he'd spent blinking between plates. Alex doesn't get to know yet whether her 13 dots, narrowed down to 1, narrowed down to a single unsettling number, will end up being remembered as the moment everything changed, or as a footnote in whatever story Rubin's decade of watching finally tells instead. Write it in the comments. Somewhere above the mountains of Chile, right now, a telescope built for exactly this purpose is doing what no telescope before it has ever been able to do. Watching the same patch of sky again and again, closely enough together in time that nothing massive, moving slowly enough to have stayed hidden for 110 years, will have anywhere left to hide. Alex still checks the alerts most mornings, the way she's checked something most mornings since the year the archive first opened its 2 old, unrelated photographs and let her line them up against each other for the first time. Some mornings there's nothing. Most mornings there's nothing. She keeps checking anyway, the way everyone in this particular 110-year-old search has always kept checking anyway, one ordinary morning at a time, for exactly as long as it takes. Nobody knows, yet, what it's about to find. It's still looking.